Welcome. This is introduction to exothermic reaction. In this type of reaction, there is release of heat into the environment, resulting into products that are lower in energy compared to the reactants. In simple terms, we are saying that there is release of heat into the environment during the reaction. Therefore, products are lower in heat content, while our reactants are higher in heat content. If we represented this information in a graph, we would have something like this. This graph is going to show relative energies of both products and reactants. So this is energy. In this axis, we are going to have reaction progress in this axis. So our reactants are higher in energy, so they must be here. Reactants, they are at higher level of energy, while our products are lower in energy. Here we are going to have our products. This region shows the heat change that occurred. In our case, heat was lost or released into the environment. So there is release simply heat released. You should note that heat content of substance is simply referred to as its enthalpy. So enthalpy is denoted by letter H. This is enthalpy or heat content of a substance, which is simply enthalpy. And the enthalpy change, which is delta H, of such a reaction is simply going to be given by heat or the enthalpy of products subtracting the enthalpy of reactants. So enthalpy of products minus enthalpy of reactants. In our case, this value is simply going to be negative. So here our enthalpy change is simply negative. In case of a real example, we are going to take sodium hydroxide pellets. It's in solid form. Dissolving it in water, we are going to get sodium hydroxide solution. The temperature will rise during this reaction. That means heat has been released into the surrounding. By releasing this heat, that means our end products, now the sodium hydroxide solution, will be low in enthalpy, or the energy will be low, since a good amount of it has been lost or released into the environment. So we are going to have reactants at high energy or at high enthalpy and products at lower enthalpy. This is sodium hydroxide solid reacted or dissolved in water. Heat is lost or released. That means our end product will have lower enthalpy. That's why we can see that it is at lower energy level. So by so doing, we can easily calculate the enthalpy of the reaction. How do we determine the general enthalpy change? It is simply the enthalpy of a product, which is a lower value, minus the enthalpy of our reactants, which have a higher value. That means we are simply going to get a negative value. Enthalpy change is simply going to be negative. If you are required to write a simple thermochemical equation for this reaction, you are simply going to write it like this. this sodium hydroxide solid dissolved in water. Simply we are going to get sodium hydroxide solution, and we usually show the enthalpy change at the end of this equation. So enthalpy change is simply negative. We can determine this value through experimental methods. So in conclusion, we can easily say that in exothermic reaction, heat is released into the environment, or heat is given out to get or resulting into products that are lower in enthalpy compared to the reactants. Welcome.